Hello everyone, welcome to another video. We are continuing on with our topic of exponential functions in this video, and we are going to start looking at the effect of changing our base number in our exponential equation or graph that we're drawing. So in the last video we looked at this example here, y equals 2 to the power of x, and we spent a long time looking at this function, and we made a few general observations about this. So one of those is that it passed through its y-intercept was 1 here, and we said that as it got down here it approached 0, it approached an asymptote of this line y equals 0. It got very close to it, but never actually touched it. So this is going to kind of extend all the way down here, and we said our exponential shoots up. So for each value of x, the y value is getting doubled. So we notice, for example, the point of 1, 2. You also had the point here 2 in the x, 4 in the y, and this just kept shooting up. Now, what we're doing in this video, and we're going to go through exponential functions quite slowly and bit by bit so we can look at all the different transformations we may encounter at this stage. So what we're going to do now, we are going to look at changing this particular number and see how this actually affects our graph. So we've got y equals 2 to the power of x. We're going to do two examples. Y equals 3 to the power of x. Now it's important to note as well, just because we're talking about functions as well, we can also write this as f of x equals to 3x. So you can practice when you do these using function notation as well. But just for ease and lack of confusion, I'm going to use this notation here, and we're going to look at this thing as well, and we're going to draw these next to our original graph, and we're going to see how this actually changes. Now you can pause this video and have a go at making a table of values if you'd like, but I'm just going to do this just so we can observe some of the effects we see when we change this number to a larger number. So let's look at, for example, x is -1, 0, 1, and 2. So here, when x equals -1, substituting that in, we get 3 to the power of -1. So that's going to give me 1 over 3. Because remember, when we have a negative power, we get the reciprocal, and the power goes on the denominator as a positive. So this is like saying 1 over 3 to the power of 1, which is just like saying 1 over 3. Now 3 to the power of 0, any number to the power of 0 gives me 1. And 3 to the power of 1 gives me 3. 3 to the power of 2, or 3 squared, gives me 9. Now, let's just look at a pattern that we see going from these numbers, because remember, when we looked at y equals 2 to the power of x, we noticed this doubling relationship between the y values here. So going from, for example, 0, 1 to 2 to 1, 2, so the 1 gets doubled to bring us to 2. The 2 in the y gets doubled to 4. So we always had this doubling relationship happening. Now here, let's look. Going from 1/3 to 1. Well, 3/3 make up 1 whole. So to get from 1/3 to 1, we can multiply this by 3. To get from 1 to 3, we can multiply this by 3. To get from 3 to 9, we can multiply 3 by 9. So we see this tripling thing happening, where each of these values in the y they're still going up at a pretty quick rate, but they are tripling now instead of doubling. So that's an interesting coincidence, but let's just see what happens with the 4 to the power of x here. So we have x, we have y, and I'll use those same points here, -1, 0, 1, and 2. So subbing in x equals -1, that gives us 4 to the power of -1, which gives me 1 over 4, 1 quarter I should say. And 4 to the power of 0, anything to the power of 0 always gives me 1. 4 to the power of 1 gives me 4. 4 to the power of 2 gives me 16. So let's just make another link here between all of these y's. What's the pattern as they change? Now, going from a quarter to 1, well, 4 quarters make up 1 whole. So we can get from a quarter to 1 by multiplying a quarter by 4. We get from 1 to 4 by multiplying by 4. We get to from 4 to 16 by multiplying by 4. Now let's look at the pattern here. The growth in y, whether this doubles, triples, or quadruples, increases relative to the number we have here, the base number. So let's actually make a note about that. The y values increase by a factor of the base number in the exponential equation. So that my y equals something. So whether this is y equals 2 to the power of x, this number here, the 2, means we are doubling the y's. For each value of x, the y gets doubled. For this one here, for each value of x, each shift in the x by 1 unit, my y triples. And here it quadruples. And you can try this for a bunch of different values, base values, this base number value. Now just remember, for some housekeeping, this is our base number, and we have our exponent up here. But the change in y is relative to the base number. Now, if we were to actually graph something like this, let's graph all of these functions that we've looked at on the same axes. So we have y, we have x. So I have my y equals 2 to the power of x here, where I have an intercept of 1, y-intercept of 1. And let's just put in for all of these a point of scale, just so we can see how each is going to increase. That gives us an idea of, because when you draw exponentials, typically they end up looking the same. So we're going to sketch including a point of scale. Okay, so let's just sub in x equals 1 into each of these exponentials we sketch out. So this point here is going to be, for y equals 2x, let's actually just label that one in. This is y equals 2 to the power of x. So for this one, I have the point of 1. When x is 1, y is going to be 2. Okay, that's a good start we've made. Just giving myself a bit more room here. Okay, now let's sketch y equals 3 to the power of x. What we're going to do here, let's do all of these in a different color. This is going to look something like this. Y equals 3 to the power of x. Now, I've just graphed this roughly. Now, I know it's going to be steeper because my y, in comparison, it's tripling. So it's going to grow a lot quicker. It's tripling. So at this point, for example, at x equals 2, y is 9, whereas in x equals to 2 in my y equals 2 to the power of x, that was going to be 4. So it's already increasing a lot quicker. So at this point, now keep in mind the intercept is still the same. And we can see that from our table of values. When x equals 0, y is always going to be 1. So it's sort of similar around here, but then it starts to shoot up when we get to positive values of x. So let's do this in another color. When x equals to 1, y equals to 3 in this case. When x is 1, y is 3. So we have the point here. Whoops, 1, 3. And one more, we're going to sketch y equals 4 to the power of x. And that's going to be this guy up here. Let's draw this up a little more. Y equals 4 to the power of x. So you can clearly see that as my base number gets bigger, my exponential shoots up quicker. It gets quite a bit steeper here. And finally, drawing in this point, let's do a color I haven't done yet. When x equals to 1, y equals 2, looking at my table here, x equals 1, y equals to 4. Whoops. I have the point 1 and 4. Now we can look at another point of scale if we wanted to. You can do this at home if you'd like. But when x equals 2, for example, you can now clearly see if I drew a line sort of straight up from here, I can see that I'm getting way steeper numbers. So you can clearly see this difference in the table of values. Here, I have 9, I have 16 when I have y equals 4 to the power of x, and I would have 4 when I have y equals 2 to the power of x. So these numbers, as you get higher and higher in x, you will see a bigger discrepancy, a bigger difference in the y values. And you can even try this for substituting in x equals to 3 and see how this changes. But you will see when you actually draw these, you get a much steeper curve as your base number gets bigger. And I'm actually going to write that down as our final key idea. As base number increases, the curve gets steeper. That is the main thing we got from actually drawing these and substituting in different values. But that brings us to the end of today's video, and we will look at a few more exponential transformations in the following few. But thank you so much for joining me, and I will see you next time.